Uh, all right, this is video 13 review because it was not clear. It was we had too much light. So now I want to review this activity because just as I have just said, it was not clear. But now I think the light is fair, so that it may be now clear to review. So what was the content of this application activity 131? 131, we had three questions. The one, the first, the second, the third. Okay, actually, the red ones are the answers. And what was the first question? So the first question was we are given these two matrices and determinant, and the question was to distinguish between this element and this element. So the answer was, of course, it was this is a 2 by 2 matrix, whereas this is the determinant. It was a question of notation because usually, matrices are written in a round bracket like this, where determinants are written in a vertical bar like absolute value, but actually they are not absolute value. It is just a notation to denote the determinant as we did here. Okay, so that was the question number one. So question number two. Question number two had the two sub-questions A and B. Now for A, the question for number two, it was to calculate the determinant of this matrix 1, 1, 1, 1, 2, 3, 1, 3, 2. So the 3 by 3 matrix to find the determinant. Now what we did was to expand it by using two methods. There were service method A and B was using expansion in cofactors. Okay, now the answer for Sarus was to add to make a augmented matrix with the two first column, the first one here, the second one there, and then to use the method as we did in class. So now the determinant by source method, the answer was -3, of course. Now the answer is here. Now B was to find the determinant of the same matrix by using expansion in cofactors of these coefficients of this matrix. Now the answer was to just use this model which shows the powers of -1, which alternate positive, negative, depending on the position of each coefficient. And now it is reduced to, so that is the this one plus, and this determinant was the cofactor of the first element, which must be multiplied there. This negative and the times the determinant of 1, 1. I have developed according to it was expanded according to the first column as it is indicated here. Okay, now so now this was the negative opposite of this determinant was the cofactor of this element. Positive 1 times this determinant was the cofactor of this element. And each time this one should be, this coefficient are multiplied in order to find the determinant by cofactor expansion. So that was number two. So number three, it was to state whether the given matrix here, A and we have B, is singular or not singular. So singular matrix here, as we pointed out yesterday, I mean in the previous video 13, Um, it was to it was so it was the video 13. No, I don't actually remember, but the previous video, because it was not clear, so it was to determine whether this matrix, this one, X is the first one, the second X is this one, was singular or not. Wow. Okay, what did we do? Okay, so A, this matrix, it is here, answer. So we found that it is not singular. Why? Just because it is a triangular matrix, a lower triangular matrix, and then its determinant must be equal to product of diagonal elements, because its determinant is 5 times 9 is 45, which means that this matrix is not singular because its determinant is different from 0. Now, B, this matrix, clearly, as we pointed out, this matrix, the answer is actually here. So, sub-question B. So, sub-question A is that the answer is that this matrix is not singular because its determinant is 45, which is different from 0. So answer for B. So this matrix, actually, this one, so along the first row, so the first row is a multiple of the second row, 4 times, or negative 4 as the multiple. So because if you multiply the second one by negative 4, so you get the first. Negative 4 times negative k is 4k. Negative 4 times the 5k is negative 20k. So now this was along the first row. Along the first column and the second column, in this case, the second one is a multiple of the first. So we have pointed out with its common factor may be negative 5. So negative 5 times 4 is 20. Negative 5 times negative k is 5k. So this is what we have just indicated. Each one of these arguments shows that we have come to show that this matrix is singular because the determinant must be 0 in case. So first of all, in case 4 negative 4k is a multiple of the first, it means that it is the matrix, its determinant must be multiplied by negative 4. We can factor it out and we have indicated that somewhere, but twice, by factoring negative 4 along the first column, the first row, sorry, this one. So we can get negative 4 out, as well as we can also get k out twice. The first time for the first row, and we get this. The second time by getting this k out, and we get this k, and then we have a determinant here. Once again, the second one is the negative 5 multiple of the first, so that we can here have this determinant can now become negative 4 times, if I factor out negative 5, it will be 20 k squared, determinant of 111. So as also it is 111, the first column is like the second column. So by properties of determinant, this is also equal to 0. Reason why we have this is one of the reasons. There are many reasons for this matrix to treat it as a singular matrix by showing that determinant equal 0. In all cases, either using this argument or this argument. So we found that in both cases it is equal to 0, or either you can also use this argument also. There are many ways actually to show that B, in case of B, this determinant of this matrix, determinant of this matrix is equal to 0, while determinant of this matrix is different from 0. That was the answer. This was the answer for question 3. Okay, that is a review of activity 1.3.1. Okay, thank you very much. I think that now everything is clear as compared to a video concerning this determinant as it was proved, as it was displayed previously. Thank you.